Sanibonani ma grade 12 sondelani ngapha sizofunda maths. So ake sibone siphiwe ini. In the statement we are told that S is the center of a bigger circle and then P is the center of a smaller circle. We are told that this line here, TR, is a common tangent. It is a tangent at Q, it is also a tangent at R. So now the first question, which is 10.2.1, we are required to prove that PQ is parallel to SR. Now, to prove that two lines are parallel, you need to remember your alternating angles, your corresponding angles, your co-interior angles. You need to remember your midpoint theorem from grade 10. You also need to remember proportionality theorem. Now, here we can see that Q1 is equal to 90 degrees. Why is Q1 equal to 90 degrees? Because we are told that P is the center, so that simple means PQ is a radius. And we are told that TR is a common tangent. So we know that tangent is always perpendicular to radius at the point of contact. So tangent is always perpendicular to radius at the point of contact. We can see also that angle TRS, we can see that angle TRS, there is TRS, is also equal to 90 degrees. Same reason, because RS is the radius of a bigger circle. So again, we have tangent that is perpendicular to radius. Now we can conclude and say, therefore, PQ is parallel to SR. So these two lines are parallel because these two angles are equal. They are both equal to 90 degrees. So why are we saying these two lines are parallel? It is because of corresponding angles that are equal. So since corresponding angles are equal, and then we can conclude and say these two lines are parallel. Now going forward, we are going to use these two lines as parallel lines. Now let's move to 10.2.2. Now we are required to prove that TP, where is TP? TP is equal to TQ, and then there is over QR, okay, and then there is that thing that is written inside here. Now, from the diagram, we can see that since we have proved that these two lines are parallel, we can say TQ over QR is the same as, here is TQ over QR, is the same as TP over PS. Why? This is a proportionality theorem. This is a prop theorem. If you are going to use this reason, prop theorem, we need to mention lines that are parallel. So because PQ is parallel to SR, so we can use prop theorem here. Now we want TP, so we can make TP subject of the formula. So on both sides, I am going to multiply by PS. Now, if we multiply by PS on both sides, we are going to have TP is equal to TQ times PS all over QR. Now, how did we get to that? we multiplied by PS. Even here we multiplied by PS. So PS and PS, they cancelled out, and then we remain with TP, and then is equal to TQ times PS over QR. Now, from here, we can see that from our required to prove, we need TP, yes, as the subject of the formula. We need TQ. We also need QR. The only thing that we do not need is PS, because instead of that PS, we need to have BP plus SR. But now from the diagram, we can see that PS is equal to, here is the line PS, here is PS, is equal to PC plus CS. PS is equal to PC plus CS, but we are not looking for PC and CS. And then again, from the diagram, we can see that this PC is equal to BP. Remember, this is a center. So PC and BC, they represent radius. So it is a radius of a smaller circle. So now we know that you can say, but PC is equal to BP. And we can see that CS is equal to SR. They represent the radius for a bigger circle. So these two are equal. Okay? And then if PC is equal to BP and CS is equal to SR, the reason here is radii. Okay? We can replace, we can say therefore our TP is equal to, and then we can replace, okay, let me just write TQ here over QR, we need these ones, and then we can replace our PS, and then simple in terms of BP. Okay, here is PS, we are writing it in terms of BP plus SR. So we are replacing this PC with BP and CS with SR. Therefore, we have proved what was required to prove. Okay. Let's quickly move to 10.2.3. And then here we have our 10.2.3. We are required to prove that triangle TQP is similar to triangle TRS. Okay, so let me just remove this similar and right end here. So these two triangles, we are required to prove that they are similar. So we can see that angle T is common. We can see that angle T is equal to angle T. This one is a common angle. We can see that angle Q1 is equal to angle R. They are both equal to 90 degrees. This one is proven. From the first question, we proved that Q1 is 90. Even angle TRS is also 90 degrees. It is proven. So that simply means even P1 is equal to angle S. This one is a third angle of a triangle. Now we can say therefore triangle TQP is similar to triangle TRS. Why? It is because of angle angle. Now, remember, every time after proving that two triangles are similar, please write the sides that are in the same proportion. So TQ over TR is equal to QP over RS, which is also equal to TP over TS. So every time after you have proved that triangles are similar, it is very important to write the sides that are in proportion. Okay, let's move to the next question. Question 10.2.4. Now 10.2.4, we are required to prove that this is equal to that. There's a lot going on here, yo. We want to prove that this is equal to that. Now, let me check my left-hand side first. What is happening in the left-hand side? So in the left-hand side, we have TS squared. Where is TS? We have TS squared this side, the hypotenuse of a bigger triangle TSR. There is CS. CS is this line, which is the same as SR. Okay, I can see already there is a Pythagoras theorem there. All right, let me first try to simplify or try to deal with my left-hand side. Now, I can use Pythagoras theorem. I know that the Pythagoras theorem says TS squared, the square of the hypotenuse, is equal to the sum of the squares of other two sides. So the other two sides are SR squared plus TR squared plus TR squared. Now, instead of SR, instead of these SR, I can put CS, because SR and CS are equal. Okay, and then now we can have TS squared minus, instead of this, I am replacing this SR squared with CS squared. It will be minus CR squared. It's not CR, but it is CS squared. Minus, okay, I have CS squared is equal to TR squared. Now, that simple means TR is equal to the square root of TS squared minus CS squared. At least now, we do have something that will link to our left-hand side. Now, let's see our right-hand side. What is happening in the right-hand side? Let me check. Okay. In the right-hand side, we have TP squared. Where is TP? Let me check. TP. Okay. Plus BP squared. Plus BP squared. Remember, BP is the same as PQ. Okay. And then TP, BP, cos of angle S. That angle there, which is the same as angle P, by the way. Remember, we have proved that these two lines are parallel. There's a cosine rule there. So let me set up my cosine rule. Okay. Okay, let me set up my cosine rule there. So I think I want to see a picture. So let me erase here above so that I'll be able to set up my cosine rule. Okay, let me erase here. So my cosine rule here, I can write TQ squared because I want to use this angle. So TQ squared is equal to, the other side will be TP squared plus PQ squared minus 2TP times PQ cos angle P1. Okay, and then now, but we know very well that P1, angle P1 is equal to angle S, even PQ, and PQ is equal to angle, not angle, PQ is equal to BP. BP. It is proven already above. So these two are radii, and then these two angles, they are corresponding. So now I can write my TQ. I can say, therefore, my TQ squared is equal to TP that we are looking for. Yes, at least we are looking for TP plus BP instead of PQ plus BP squared minus 2TP squared times BP squared cos. Instead of P1, I'll put angle S because there, in my required to prove, there is S. And then from here, I can put, oh, why did I put squared there? There is no squared there. So there is no squared. It will be just, yeah, there's no squared there. Okay. And then from here, I can make a TQ subject of the formula by squaring on both sides because I want that square root there. So I have TQ is equal to square root of TP squared plus BP squared minus 2TP BP cos angle S. Okay, let's see, where are we heading? This one is not easy, to be quite honest. Okay, we are almost there. But now we still need this BP and CS. Let's go back to our ratios again. So we have TR, there is TR. We have TQ, there is TQ. We also need BP, if I'm not mistaken. So, okay, from the ratios, do we have BP? But remember, BP is the same as PQ. So here is PQ. And then we also need CS. CS is the same as SR. So there is SR. So we need to go back and say, but remember that our TQ over TR, okay, is equal to QP over RS. Why? This is coming from similar triangles. Okay. And then now from here, we can make, okay, let me see. We can, because we can see here that this TR, here is TR is the subject of the formula. We can make a TR subject of the formula. So if I make TR subject of the formula here, I am going to have a TR I am going to have TR is equal to cross multiply is equal to TQ times, it will be TQ times RS, okay, over QP. Now, instead of TR, I'm going to put this. So we are going to have the square root of TS squared minus a CS squared is equal to, and then do we need TQ? No, we do not. Instead of TQ, we can put all this, and then it will be the square root of TP squared plus BP squared minus 2TP BP cos S. And then now, do we need RS? No, but instead of RS, we can say multiply by, we can replace this RS with what? With, from the diagram, with CS. CS all divided by, do we need QP? No, instead of QP, we can just put BP. So we have proved what was the part to prove. Hey, this one is difficult, sure. But thank you very much for watching. It is an interesting question.